Welcome to chemistry classes. In this video we have to discuss here applications of Ellingham diagram. We already discussed Ellingham diagram in previous video. You have to watch isolation of metal part 2, then you have to watch this video. Okay, so here applications of Ellingham diagram. First one, we have to discuss here extraction of iron. Extraction of iron. We know the ore of iron is hematite. To extract iron, we will use blast furnace. This figure represents blast furnace. Okay, from the top of the blast furnace, we will add charge. We will add charge. Charge means mixture of three substances. Mixture of limestone, coke and hematite. Okay, this mixture is called charge and it will add from the top of the blast furnace, and we will pass hot air from the bottom part. We will pass hot air. That's why this furnace called blast furnace. We will pass strong hot air from the bottom part of this furnace. Okay, after passing hot air and charge, there are many chemical reaction, and here iron ore reduced to iron and carbon monoxide. Okay, FeO reacted with carbon formed iron and carbon monoxide. This is the first chemical reaction. We can say this chemical reaction happening in two simple steps. This chemical reaction happening in two simple reaction. This is the first reaction. Iron oxide change to iron and oxygen. This is the first step. Iron oxide change to iron and oxygen. And this is the free energy change of this chemical reaction. Second step, here carbon reacted with oxygen form carbon monoxide. First step, iron oxide change to iron and oxygen. Second step, carbon reacted with oxygen formed carbon monoxide, and these are the free energy change for first reaction and second reaction. So free energy change for overall reaction will be, we have to add this free energy change and this one. So free energy change for overall reaction is free energy change of first reaction plus free energy change of second reaction. Then according to Ellingham diagram, we know to happen this chemical reaction, delta G must be negative. Delta G for this chemical reaction, for overall chemical reaction, delta G must be minus for feasibility of this chemical reaction. Okay, for spontaneity of this chemical reaction, overall delta G must be, overall free energy change must be minus. Clear? Next one, see this diagram. This is Ellingham diagram, and this diagram helps us to understand which reducing agent is better to reduce iron oxide to iron. So look here, this is delta G against temperature. We discussed already this type of diagram in previous video. Okay, so here this line, look here, this line represent reduction of iron oxide, and here this line represent carbon change to carbon monoxide, and here carbon to carbon dioxide, and here carbon monoxide to carbon dioxide. There are three reducing agents. Okay, three reducing agent: carbon to carbon monoxide, carbon to carbon dioxide, carbon monoxide to carbon dioxide. Okay, three different chemical reaction. So which chemical reaction, which one is better reducing agent for iron oxide? This diagram help us to understand, help us to choose better reducing agent and better temperature. Okay, we discussed already to choose a better reducing agent. This is metal oxide line. This is metal oxide line, and the reducing agent, the line for reducing agent must be below this line. We have to choose a reducing agent and its line must be below this line. Also its delta G must be negative. I told you in previous video, here this is delta G 0, below this delta G minus, above this delta G positive. So we have to choose a line below metal oxide line. Also delta G must be negative. And third condition, lower temperature. When you are coming this direction, temperature will be increases. We have to choose a lower temperature. So which one will be better reducing agent? Carbon to carbon monoxide, carbon to carbon dioxide, or carbon monoxide to carbon dioxide? Which chemical reaction happening or which chemical reaction is spontaneous for reduction of iron oxide to iron? So out of these three, this one will be spontaneous reaction. This is okay, carbon monoxide to carbon dioxide, because look here, this is metal oxide line, this is metal oxide line, and this line is below metal oxide line, this one below metal oxide line. So it first condition satisfied. Also this is delta G 0, it is below this one. So here delta G is minus. Here below here carbon monoxide to carbon dioxide below metal oxide line. Also here delta G is minus, and here look here, it is left side, not this right hand side, it is left side. So it is lower temperature. Here lower temperature and delta G minus, and also it is below metal oxide line. So all condition will be satisfied. So here iron oxide reacted with carbon monoxide, it will change to iron and carbon dioxide. So out of these three different chemical reaction, this chemical reaction is feasible, this chemical reaction is most spontaneous chemical reaction. Clear? Okay, so see here, this is blast furnace. We already discussed. We will add charge from the top of the blast furnace and we will pass hot blast air from the bottom part. Hot blast air which consists of oxygen. This oxygen will react with coke. Coke means carbon. Coke reacted with oxygen form carbon monoxide and heat. Coke reacted with oxygen form carbon monoxide and it is exothermic reaction. It produces large amount of heat energy. Coke reacted with oxygen form carbon monoxide. This carbon monoxide again react with another coke, another carbon atom. It produces carbon monoxide. Okay. So here I said we already discussed, we will add charge from the top of the blast furnace and we will pass hot blast air from the bottom part. Coke reacted with oxygen form carbon monoxide. It is exothermic reaction. It produces large amount of heat energy. Carbon monoxide formed again react with another coke. It formed carbon monoxide. Okay, this carbon monoxide helps to reduce iron oxide to iron. We discussed in Ellingham diagram, carbon monoxide reduce iron oxide to iron. Look here, carbon monoxide reacted with the iron oxide, it changed to iron and carbon dioxide. Okay, and here delta G for this chemical reaction is most negative, and this chemical reaction is most spontaneous chemical reaction. Clear? So here these are the iron oxide. In the ore of iron there are iron oxide and there will be FeO and Fe2O3. FeO in presence of carbon monoxide, it changes to iron and carbon dioxide. Similarly, there is Fe2O3. Fe2O3 in presence of carbon monoxide also change to iron and carbon dioxide. These are the chemical reaction for reduction of hematite, reduction of iron oxide to iron. Clear? Also, in blast furnace, the bottom part of blast furnace, there will be very high temperature. At a high temperature, this chemical reaction happen. At a very high temperature, coke will react with oxygen, form carbon monoxide. Okay, this carbon monoxide also reacting with another coke, it forming carbon monoxide. This chemical reaction happening at very high temperature. Very high temperature mean around 900 to 1500 Kelvin. This chemical reaction takes place at very high temperature. I told you before, coke reacted with oxygen form carbon monoxide. It is exothermic reaction. It produces large amount of heat energy. Okay, so this type of chemical reaction helps to produce higher temperature inside blast furnace. Okay, also I told you charge mean limestone mean calcium carbonate. Calcium carbonate at very high temperature, calcium carbonate changes to calcium oxide and carbon dioxide. At very high temperature, calcium carbonate changes to calcium oxide and carbon dioxide. This calcium oxide reacted with the silica, it formed calcium silicate. We know ore which contain impurity. Okay, ore of iron which contain impurities such as silica. Silica is gangue. Gangue means impurity present in the ore. So here this calcium oxide reacted with the impurity, it formed calcium silicate. This calcium silicate is slag here, slag. Okay. So these are the different chemical reaction taking place in blast furnace. At very high temperature, in lower part of blast furnace, coke reacted with oxygen formed carbon monoxide. This carbon monoxide and carbon dioxide. At lower part, coke reacted with oxygen formed carbon monoxide and carbon dioxide. The carbon dioxide formed, again reacting with the coke, it formed carbon monoxide. This carbon monoxide helps to reduce iron oxide to iron. Okay. Also at a high temperature, in lower part of blast furnace, calcium carbonate decomposed to form calcium oxide and carbon dioxide. Calcium oxide reacted with the silica, it formed calcium silicate. Calcium silicate. Okay, calcium silicate is slag. Okay, next one, we have to understand here three different types of iron. Depending upon the carbon content, we can say there are three different type of iron: pig iron, cast iron, and wrought iron. Pig iron, cast iron, wrought iron. Pig iron, the most carbon content iron is pig iron. Pig iron, which consists of around 4% carbon and other impurities. Other impurities such as sulfur, phosphorus, silicon, manganese. These are the other impurities present in pig iron. Pig iron, which consists of 4% of carbon. Okay, next one, cast iron. Cast iron, which consists of around 3% of carbon content. 3%. The previous one 4% of carbon content, here less than 4. Okay, around 3% carbon content. Okay, and here cast iron produced from mixture of molten pig iron and scrap iron. The molten form of pig iron and scrap iron mixed together to form cast iron. Cast iron, which contain impurities, also which contain 3% of carbon content. That is cast iron. Third one, wrought iron. Okay, wrought iron, almost pure form of iron is wrought iron. Here very less carbon content. Okay, less than 0.5% carbon content. Okay, wrought iron which contain less than 0.5 percentage of carbon content. Also it contains some other impurities. Okay, and it is malleable form of iron. Malleable form of iron is wrought iron. Okay, because of the less carbon content, it is malleable form. Clear? These are the things we have to understand about extraction of iron. Clear? Okay, next one we have to discuss here extraction of copper. Extraction of copper. Here copper ore which contain copper oxide or copper sulfide. Okay, the ore of copper which contain copper oxide or copper sulfide. Copper sulfide on strong heating it will change to copper oxide and sulfur dioxide. Sulfur dioxide gas escape outside and left behind copper oxide. Copper oxide reduced with carbon we will obtain copper and carbon monoxide. These are the chemical reaction taking place during extraction of copper. Look here copper ore of copper which contain copper sulfide. On strong heating it changes to copper oxide and sulfur dioxide. I told you sulfur dioxide gas escape outside left behind copper oxide. Copper oxide reduced with carbon it form copper and carbon monoxide. Clear? But in actual process in factory, chemical factory, we will extract iron by this method. These are the chemical reaction according to laboratory method. We can say extraction of copper chemical equation like this, but in actual process these are happening. The ore of copper pyrites, CuFeS2, copper pyrites, this is the ore of copper. Okay, this ore mixed with silica and heat very strongly in a furnace. Okay, after strong heating, copper pyrites reacted with oxygen, it formed copper sulfate, iron sulfide and sulfur dioxide. Okay, this is ore of copper pyrites. On strong heating it formed copper sulfide, copper oxide and sulfur dioxide. Sulfur dioxide gas escape outside. Look here, the mixture of copper sulfide and iron sulfides. Look here, I told you before, copper pyrites on strong heating, copper sulfide and copper oxide, not copper oxide, on strong heating with oxygen, copper sulfide, iron sulfide and sulfur dioxide. Okay, copper pyrites on strong heating, copper sulfide, iron sulfide and sulfur dioxide. Sulfur dioxide gas escape outside. Okay, mixture of copper sulfide and iron sulfide, this mixture is called copper matter. It is called copper matter. Clear? Next we are going to talking about iron sulfide. Iron sulfide on strong heating it form iron oxide and sulfur dioxide. Okay, here copper CuFeS2 on strong heating, copper sulfide and iron sulfide is formed. Now I am talking about this iron sulfide. Iron sulfide again strong heating it will change to iron oxide and sulfur dioxide. Again sulfur dioxide escape outside and left behind iron oxide. Okay, we added here silica. Silica means SiO2. Iron oxide formed, reacted with silica, it formed iron silicate, FeSiO3. Iron silicate forms slag. This is slag. Okay, now we have copper sulfide. Copper sulfide on strong heating, it formed copper oxide, sulfur dioxide. Copper oxide and sulfur dioxide. Again sulfur dioxide escape outside. Copper oxide again reacted with another copper sulfide. Look here, copper oxide reacted with copper sulfide, it forms copper and sulfur dioxide. So these are the chemical reaction happening in actual extraction process of copper. I will repeat once again. The ore of copper is copper pyrite CuFeS2. On strong heating it forms copper sulfide, iron sulfide, sulfur dioxide. Mixture of copper sulfide and iron sulfide, it is called copper matte. Iron sulfide on strong heating it forms iron oxide, sulfur dioxide. Iron oxide combined with silica it forms iron silicate. Now left behind copper sulfide. Copper sulfide also after strong heating form copper oxide, sulfur dioxide. Always sulfur dioxide gas escape outside, copper oxide left. This copper oxide reacted with unreacted copper sulfide. Look here, copper oxide reacted with unreacted copper sulfide. It formed copper and sulfur dioxide. Now we extracted copper. These are the chemical reaction happening in actual extraction process of copper. Clear. Next one, we have to discuss here electrical principles of metallurgy. Electrical principles of metallurgy. We know Gibbs free energy equation delta G. We know free energy equation delta G equal to minus NFE0. Here delta G, again free energy change. N mean number of electrons, F Faraday constant, E0 represents standard electrode potential. We know here E0, standard electrode potential for highly reactive metal, it will be negative value. Okay, here this E0 will be highly negative for more reactive metal. Okay, in such situation, reaction is not spontaneous and reduction of such type of metal oxides are highly difficult. In such situation, we will use electrolysis of molten metal ion. Okay, so here electrolysis of molten metal ion, electrolysis of molten compound. After conducting electrolysis, metal ions such as Mn plus represent Na plus, Al3 plus, generally M represent metal, and N plus maybe plus 1 plus 2 plus 3 plus. Okay, generally this Mn plus represent metal ions. So highly reactive metals on the top of reactivity series, they are highly reactive and reduction of such metal oxides are highly difficult, and we will use electrolysis of molten compound in such a situation, and metal ion will be reduced at negative electrode mean cathode. Okay, metal ion will be reduced at cathode. Clear? Okay, next one, we have to understand here extraction of aluminium. Aluminium is extracted by electrolysis. Okay, the ore of aluminium is bauxite. The formula of bauxite Al2O3 XH2O. Al2O3 with water molecule, that is bauxite, and it is the ore of aluminium. Okay, alumina mean Al2O3. Without water molecule, it is called alumina. During extraction of aluminium, molten mixture of an Al2O3, Na3Al F6 and CaF2. All this in molten form. Okay, it is used as electrolyte. Na3Al F6 called cryolite. Okay, here molten mixture of alumina, Na3AlF6 and calcium fluoride used as electrolyte. Okay, and here Na3AlF6 and CaF2, This helps to reduce melting point of alumina. Actually, alumina has melting point more than 1500 degrees Celsius. When we use molten mixture of cryolite calcium fluoride with alumina, this things helps to reduce melting point of alumina from 1500 degrees Celsius to 900 degrees Celsius. Okay, so it helps to reduce expense. Also, it helps to increase conductivity of electrolyte. When we mix molten alumina, cryolite and calcium fluoride together, conductivity of electrolyte increases. That's why we using here molten mixture of calcium fluoride Na3Al F6 with alumina. Clear? And look here, this diagram here, this type of container used for electrolysis. Okay, a steel container used for electrolysis of molten aluminium. The steel container, inner part of steel container lined with carbon. This carbon, inner part of steel container lined with carbon, this carbon lining act as cathode. And big blocks, you can see the diagram, big blocks of carbon introduced into container. This big blocks of carbon act as anode. Okay, so both cathode and anode made of carbon, or you can say graphite. Clear? After passing electricity, here alumina will change to, at a very high temperature, here alumina will change to Al3 plus and oxygen. After passing electricity, here this Al3 plus cations will deposit at cathode. Al3 plus will deposit at cathode and molten aluminium will be formed on the bottom part of the container and we can separate it. Okay, also here oxygen gas will be liberated at anode. I told you before, anode is made of carbon. Okay, so oxygen gas liberate at anode. Oxygen gas react with carbon anode and it produce carbon monoxide and carbon dioxide. Okay, so these are the different chemical reaction taking place during extraction of aluminium. Also look here, this is the overall chemical reaction during extraction of aluminium. Here Al2O3 plus carbon, aluminium and carbon dioxide. So you understand here, during extraction of aluminium, alumina used as molten alumina used as electrolyte. Mixture of molten alumina, cryolite and CaF2. After passing electricity, here Al3 plus will deposit at cathode and O2 minus will deposit at anode. Oxygen reacted with carbon anode formed carbon monoxide and carbon dioxide. Okay. Formation of carbon monoxide and carbon dioxide, highly exothermic reaction. Okay, and there is possibility for explosion during this process. That's why this carbon anode will be taken out from the container frequently. Clear? These are the things you have to understand about extraction of aluminium. Okay. Also, these are the things we have to discuss in this video. Rest of the part we will discuss next video. Okay. So thank you for watching this channel. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.